These are presentations designed for pest management professionals. So not everything covered here is going to fit your life precisely. The materials that are presented are going to be based on the National Core Pesticide Safety Education Manual. The page numbers you will see during the presentation refer to pages in that manual. If you want more information on the topics, those are the pages to go to in the manual. If you want the National Core Manual, go to the USU PSEP Facebook page and you will find a link there to the materials. All right, here we go. Let's see how this works. So we're going to start with chapter 1, which is pest management. We are not covering the entire chapter. We are just covering a portion of it. So sometimes when nature doesn't control our pest populations or keep them at sufficient numbers, then we get involved and implement control tactics to reduce the pest population. We use things called applied controls. Those include biological, mechanical, cultural, physical, genetic, chemical, I think I said that twice now, and regulatory methods. We're going to look at each of these individually here. So what is a biological control? Biological controls rely on the pest's natural enemies, such as birds, insects, fungus, and viruses. Applied biological control is often directed against a pest that is a non-native pest in the geographic area it's found. When a non-native pest invades, it often doesn't come with its complement of predators, parasites, and pathogens. So scientists will visit the range from which that native pest came from. They'll evaluate the suitability of releasing a natural enemy into the area where the pest is a problem, and then hopefully it will become established. As the newly released natural enemy population grows, scientists will redistribute the beneficial organisms to other sites where the pest has become established. In undisturbed natural areas, so places like forest, rangeland, and other sites, biological controls have a good chance of becoming self-sustaining. In other more disturbed areas, like landscapes, greenhouses, the pest management person may need to release biological control agents regularly. Introduction of biological control agents is strictly controlled because of the concern of that biological control agent running amok. There are several instances where the biological control agent have become a pest themselves. One example is the cane toad in Australia. The toad was introduced to control two types of beetles that were decimating the sugarcane crop, but the cane toad itself became an exemplary example of what we call a feral species, which is just another term for an invasive species. Again, depending on the establishment level of the biological control, periodic releases may be required in natural areas, greenhouses, landscapes, and agriculture. Any person who's considering a biological control or considering, pardon me, a pesticide application should take into account the beneficial organisms to determine if an application is necessary and won't decimate that population. Your management plan should be designed to conserve the natural enemies. Environmental modifications such as plant cover crops and ground covers may enhance natural enemy populations. If you have predatory and parasitic insects present, be careful and select the type of insecticide you use. Be careful in the selection, of the insecticide you use. Broad spectrum insecticides often kill natural enemies, such as some selective insecticides don't kill the beneficials. So consider non-chemical control options to ensure conservation of these natural enemies. Another type of applied control is mechanical, the favorite stomp or squish that bug control. Mechanical control involves using devices, machines, or other physical methods to reduce pest populations. They also use mechanical means to alter the environment so that it is unsuitable for the pest to survive. Cultivation is one of the more common forms of mechanical control. Hoes, plows, discs, mowers, cultivars, and bed conditioners are all mechanical devices that physically disrupt soil conditions. If you disrupt the soil, you can manage certain types of weeds, germinating weeds, seeds, and soil insects. Mowing can suppress certain types of weeds and destroy others. Exclusion is the use of a device that blocks the entry of the pest into the specific area. This may be a screen on a window to keep out mosquitoes, or caulking to keep rodents and ants out of structures. Sealing cracks and crevices keeps insects and rodents, bats and birds out of buildings. Metal tree collars can be used to keep squirrels from climbing the trees, and sticky materials painted on trees, posts, and wires provide a barrier that many insects don't want to cross. Using sharp objects on roosting areas prevents birds from congregating, and these are all examples of exclusion. Certain rodents and insect pests may be successfully managed with trapping. The trap may consist of a holding device, a leg snare, leg hold trap. Some traps capture animals live and they are relocated or euthanized. Traps that have sticky surfaces don't allow the insects or rodents that come into contact with them to escape. Cultural controls alter the environment in which the pest lives. The environment may be changed so it is unsuitable for the pest, or the environment may be altered so the host plant grows more healthfully and is less susceptible to attack by a pest. For example, when turf is managed properly through mowing, irrigation, aeration, and fertilization, it is less likely to have weeds, insects, or disease problems. Mulching in landscape beds prevents light from penetrating and greatly reduces weed seed germination. Selecting crop cultivars or landscape plants that are not susceptible to pests pressures is a key factor in preventing pest control, or in preventative pest control. It's a hard word on a Monday morning. Lost my spot. Here we are. Simply by changing planting dates, you can significantly reduce pest populations. The pests may emerge prior to the host plant being present, and if it dies off and then the crop germinates, you're ahead of the game. Or you may plant early to get the crop a head start so it can outcompete the pest. In agriculture, the use of crop rotation and trap crops often reduces pest pressures on their crops. A pest cannot survive if it doesn't have food, water, and shelter. Practicing sanitation reduces the source of the pests, or it eliminates the food and water sources. If you have infected plant residues, they must be removed from the site and destroyed. Weedy areas near buildings, crop fields, or landscape provide areas for pests to hide. If rodents and some insects have access to food like manure or garbage cans, they'll be present and reproduce. Having soil near siding provides habitat for certain structural pests. Learning about the habitats of your key pests, evaluate your area for places where the sanitation can be effective, and reduce the pest numbers. Physical control is the altering of the physical environment. So changing the humidity, temperature, airflow, water, and/or light. Managing a pest can be as straightforward as pruning landscape plants to increase airflow and light penetration. More air movement and light in the plant's canopy reduces the amount of free moisture present and makes it unfavorable for pathogens. Lowering humidity and temperatures in the stored grains prevents mold and insect infestations, increasing air circulation in structures, suppresses wood rot caused by fungal growth, and bright lights in attics can be used to deter bats. Plant breeding and selective resistant crops or landscape cultivars can prevent pest populations. This is true for livestock as well. Traditional breeding programs select for characteristics that prevent attack by diseases and parasites. Genetic manipulation is becoming more common to acquire plants that have tolerance for pests or can tolerate herbicide treatments. Chemical controls can be part of an IPM program, IPM meaning Integrated Pest Management. A pesticide is definitely defined as any material that is applied to a plant, the soil, water, harvested crops, structures, clothing and furnishings, or animals to kill, attract, repel, or regulate, or interrupt the growth and mating of the pest, or to regulate plant growth. The broad category of chemicals termed pesticides includes your disinfectants, fungicides, herbicides, insecticides, nematicides, repellents, defoliants, and desiccants, to name a few. Unfortunately, often people use the term pesticide and insecticide as synonyms, when in fact an insecticide is only one type of a pesticide. Pesticides can be quite effective, quick-acting, and relatively easy and safe to use if you pay attention and read your labeling. The government also uses regulatory control programs to manage pests. Quarantines are used at airports and ocean ports to prevent entry of foreign pests. State borders and areas within states may be under quarantine status to prevent the movement of pests from an infected area. Nursery stocks and other plant materials may be regulated to ensure no pests are transported on plant material. Let's try that again. Nursery stocks and other plant materials may be regulated to ensure that no pests are transported on plant materials. Federal and state government agencies may be involved in small to very large scale eradication programs, with the goal being to totally eliminate a pest from an area. Regulatory mosquito abatement districts and programs are established to manage large scale public health concerns. So IPM, we mentioned it briefly. Why practice IPM? The shift from using only a single control tactic to IPM provides for a more balanced ecosystem, since factors other than damage alone are part of the decision making. We know that continued use of pesticides without thoughts of resistance management and effects on the environment can result in products becoming less effective. Using IPM promotes a healthy environment and saves you money over the long run. Integrated Pest Management, IPM, is a decision-based management system that implements a balanced tactical approach. The decision-making is based on planning to anticipate damage, to prevent it from occurring, and if damage thresholds are met, using a variety of control tactics to suppress the pest population. When using a decision-based system, you increase effectiveness and reduce the negative side effects. IPM is dependent on proper identification and understanding of the pest biology, along with proper measurement of population densities and assessment of control tactics. Here are the major factors that drive the decision-making within an IPM program. First and foremost, you must properly identify, correctly identify, and understand the pest. Once you know what when and where about the pest. You can develop a monitoring system using several survey techniques. You need then to set your management goals and decide what level of control is acceptable for your situation. A golf green, for example, will have a different goal than a golf fairway. Once you set your goals and understand the pests, you can look at the factors that impact your selection of control tactics. These factors may include timing, economics, environmental considerations, and regulatory constraints. Don't forget to evaluate the entire process and record your findings. You can then tweak the plan in future years once you understand your successes and failures. So let's look at some of these considerations in a little more detail. Pest identification is critical. It's the most important step in the process. You must know what pest is causing the problem or may potentially cause another problem. Often an insect or a plant present may pose no threat or require no action. So some may even be beneficial organisms. Once you have identified the pest, take some time investigating its classification and life cycle. These are key to mechanical, cultural, and chemical management options. Knowing the stage of the pest that overwinters may provide a key to the timing for control measures. Investigation is critical to understanding what pest population levels trigger concern and what levels trigger action. Excuse me. Having some knowledge of pests and its environmental needs may shed light on what population levels may be acceptable due to environmental conditions. Did the cold weather knock the population back? Did the early warm spring allow another generation to be produced? Knowledge of the life cycle may provide keys to timing the control activities to pest's most vulnerable stage. Monitoring the pest. If you have a working knowledge of the pest, you can learn about scouting and trapping techniques. Some scouting depends on weather data, since growth of pest populations depends on temperature. Several factors will play into the decision when evaluating the trigger levels for control actions. These may be based on economics, yield of harvest, harvest cost, or they may simply be based on aesthetics. You have to know the answer to the question, how many pests need to be present before the control action is warranted? In some cases, one mouse is enough, and then you take action. Development of your goals. You need to set your goals. Prevention is an important goal during your planning period and prior to the seeding or establishment of a bed of turf grass. Consider what actions can prevent pests from becoming established. Consider certified weed-free seed or resistant cultivars. Build exclusionary devices to keep pests out if you had a previous infestation. Consider a sanitation. You may want to consider preventing pesticide treatments, preventative pesticide treatments, pardon me. Do you require total elimination or just suppression of the population? There are many tactics to hold populations in check. If your goal is eradication, which it almost never is, you'll have to develop a very intense methodological plan to ensure elimination of the species and all of its life stages. Eradication is typically a goal when you have a very small contained pest population or when the government is managing the program and they want and they can employ wide-scale control activities on properties and private citizens. Always follow these steps before implementing your IPM program. Identify the pest and set up a monitoring program. Know the economic or action thresholds as well as the economic injury levels. Consider the available management options, evaluate the benefits and risks of each method, and make sure your control strategy falls in step with any regulations. A very important step in IPM programs is the recording and evaluation of your efforts. Keep track of the climate conditions, record when and where actions were taken, track the pest populations. Near the end of the season, review your records. Some control strategies may not be quick acting, but may prove effective given sufficient time. Other management strategies may have caused negative impacts that need to be considered when making future decisions. Consideration of pesticide use. When you look to chemicals as a management option in your IPM plan, this is typically your last step. You will try the other control options first. There are several things to consider when you do consider chemicals. First, make sure you have identified the pest correctly. Make certain that the product you select is effective against the pest and is labeled for the site. If you have had a continual problem with pests, your decision on chemicals may be slightly different than if you are targeting a new invasive pest. If you have used chemicals in the past to treat a pest population, consider using an alternative type of product to reduce the possibility of pesticide resistance. The goal here is to make sure that you change active ingredients. If you keep using the same product with the same active ingredient repeatedly, year in and year out, resistance will likely develop in the population. Make sure you read the label carefully to understand the timing for the application and make sure you use correct application rate. Using a dose that is over the label rate is illegal and can cause significant impacts. For example, using too much of a selective herbicide may result in damage to your crop or turf. Make an application with too low of an Making an application with too low of a dose or at the wrong time can be a waste of time, money, and effort. That is the quick and easy review of Chapter 1, Pest Management. Hopefully this has streamed to Facebook properly. I am going to end the slideshow and stop my screen share and see what we have.